welcome to the section of this course. Today I will be speaking about the first principle of derivative for exponential functions. Okay. Now let's solve from easy one. After that we'll pick up the difficulty levels of the derivative. Okay. Exponential functions. Okay. Let's take first example. Let f of x equals to e raised to x. It's a very simple function, okay, exponential function, or you can say e raised to x square or anything. So let's take simple example. Now since f of x is this, then f of x plus h will be what? Instead of x, you have to write e raised to x plus h. Okay, by first principle, or you can say ab initio method, we have limit of f of x plus h minus f of x upon h, where h tends to 0. Okay, this is what? This is your f of f dash x. Okay, or you can say this is dy by dx. Okay, this is your differentiation. Okay, this is what you want. Now f of x is here, f of x is here, you substitute here and take limit where h tends to 0, okay, is equals to limit of h tends to 0, f of x plus h is what? E raised to x plus h minus e raised to x upon h, okay. From here, we can take e raised to x common. Why? Because e raised to x plus h is same as e raised to x into e raised to h. Why? Because if base are same, we can add the indices. It is our formula a raised to m plus m is same as a raised to m into a raised to n. If base are equal, we can add the power or indices. Okay. From here, I can take what? Limit of h tends to 0. I can take e raised to x common. What I have? E raised to h minus 1 upon h. Now when h tends to 0, okay, this term when h tends to 0, this term is what? 1. Okay, log e is always 1. Okay, therefore this whole term when h tends to 0 become a 1. So what we have is, we have only e raised to x. Okay, therefore by first principle, e raised to x, differentiation of e raised to x is what? E raised to x itself. Okay. Let's take another example. Let's take 2. If it is f of x equals to e raised to x plus 1. Okay. Now let's take function f of x equals to e raised to root 2x. Now let's take function f of x equals to e raised to square root of 2x. Okay. Now you know that limit of e raised to x minus 1 upon x, where x tends to 0, is log of e to the base e, means it has 1. Okay, remember this limits, this x should be same as this x. Okay, then when x tends to 0, e raised to x minus 1 equals to log of e to the base e is 1. Now this f of x equals to e raised to root twice x, we have to solve, we have to find derivative by first principle. Okay, since fx is this given, f of x plus h is what? Instead of x, we have to write x plus h. So e raised to 2 of x plus h square root. Be careful. Here you cannot write only 2x, 2x plus h. Okay, this x, instead of x, you have to write x plus h. Okay, therefore this is same as e raised to 2x plus 2h the square root. Okay, by first principle we have limit of h tends to 0, f of x plus h is this, e raised to square root of twice x plus twice h minus e raised to square root of twice x upon h. Okay. From here, if I want to take limit of h tends to 0, if I want to take e raised to 2x common, okay, if I want to take e raised to root 2x common, what will be its value? Okay, it is same as e raised to root of twice x plus 2h, okay, minus e raised to, or you can keep like this, or you can keep like this. I will write this if I am taking this common, okay, or you can do like this, into 1 upon e raised to root 2x minus 1 upon h. Everyone is okay? What I am doing is I am taking e raised to 2x common, okay. This and this gets cancelled. This into this is become a this, okay, and this into this is this, okay. Now this I can bring up limit of h tends to 0, e raised to square root of 2x in bracket, this I can bring up e raised to square root of 2x plus 2h into e raised to minus square root of 2x, okay, minus 1 upon h, okay. This, if base are equal, so I can add the powers, okay. So limit of h tends to 0, since it is free from h, so we can keep outside also e raised to 2x. Here e raised to what? E raised to twice x plus, remember, for example, a raised to this is same as e raised to, base are same, okay. So base, since base are same, we can add the indices 2h plus this plus minus square root of 2x minus 1 upon h, okay. Now remember, e raised to x minus 1 upon x is, this is our something like x, okay. We need this, okay, into this h, okay. E raised to x upon, e raised to x minus 1 upon x, this upon this, okay. Now square root of a into b is square root of a into square root of b, but square root of a plus or minus b is not same as square root a plus minus square root of b, okay. So we cannot break this also, okay. Now e raised to x, so let's see, okay, limit of x tends to 0, e raised to x minus upon x equals to log of e raised to the e. These terms should be same as this term, okay. Now this term we need, okay. So what we can do is over here, this h I will write over here, okay. This term we require, okay, in order to apply this formula, or in order to apply this formula, this term we need, okay. Here twice 2 I can take common, okay, or you can keep like this, twice x plus twice h minus root 2 x, this is we need, okay. So this same term right on over here will get cancelled, okay. Here root of 2x plus 2h minus root 2x, okay. This and this gets cancelled, okay. Why I am writing? Because this e raised to some x should be same as this minus 1. In order to apply this formula, so I am adjusting this and this gets cancelled, okay. Therefore limit of h tends to 0, this, okay, this become a, when h tends to 0, look at here, when h tends to 0, this become a 0. When h tends to 0, means twice h become this and this gets cancelled, this become a 0, means when x tends to 0, this is 0, this is 0, then log of e upon e. Therefore, this is 1. Okay, whole term is become a 1 when h tends to 0. E raised to root of twice x into 1. Okay, limit h tends to 0. Why I am taking outside? Because this is free from limit. Okay, now this, okay, now I can rationalize its conjugate. Okay, minus, if it is minus, so plus up and down. So what I can do is I can take even 2 common, so I will take later on. Square root of twice x plus 2h minus root 2x upon h into plus up and down, okay, into square root of twice x plus h plus root 2x upon square root of twice x plus h plus root 2x. Okay, here it is out from a minus b into a plus b. It is out from a square minus b square. Okay, now it is of the form here. This is constant. Okay, this is constant. It means h tends to 0. Okay, now here a minus b, it is of the form a minus b, a into a plus b. Okay, here into this into this or a square minus means a minus b into a plus b equals to a square minus b square. Okay, therefore what we have is this e raised to square root of twice x into 1, limit of h tends to 0, square root. Okay, here 2x plus 2h the whole square root the whole square. Okay, minus root 2x square root the whole square upon h into what we have, square root of twice x plus, it will be what? It will be twice x plus twice h. Okay, twice x plus twice h minus plus square root of twice x. Now e raised to root of 2x, this square root and square gets cancelled. Okay, here gets cancelled, here also square root and square gets cancelled, and this 2x and 2x gets cancelled, this 2x and 2x gets cancelled. What we have is here h also h gets cancelled. Okay, h and h also gets cancelled. When h tends to 0, this term is 0. Okay, what we have is 2 upon root 2x plus root 2x is same as root 2x in e raised to root twice x, 2 upon here root 2x with 2x is 2 root 2x. This gets cancelled. Is we can write e raised to root 2x upon root 2x, or you can bring this up. Okay, this is you can answer for e raised to root 2x. Okay, welcome to the section of this course. Let's take again one question. Question A: if f of x equals to e raised to cos x, exponential function. Okay, exponential rise to trigonometric function. Okay, now since f of x is this, f of x plus h is what? E raised to cos of x plus h. Okay, therefore limit of h tends to 0, f of x plus h is what? This is, okay, this is my f of x plus h. It's e raised to cos of x plus h minus e raised to cos x upon h. Okay, now here can you take cos x common? Okay, if I take cos x common from here, let's see what will happen. Limit of h tends to 0, e raised to cos of x plus h Okay, I am taking what? Minus 1 will come, e raised to cos x. Okay, now what will come here, over here? Okay, so if I do 1 upon e raised to cos x, because e raised to cos x will get cancelled. This I am getting, but e raised to cos x into 1 is e raised to cos x. Okay, now this I can bring up. Limit of h tends to 0, e raised to cos of x plus h minus, okay, it become minus cos of x minus 1 upon h into, you can say, cos of x, I write here h. Okay, here h. This is my e raised to cos of x. Okay, now cos of x plus h is over here, e raised to what? E raised to minus cos x. Okay, base are same, so I am writing minus over here. Now we have limit of e raised to x upon e raised to x minus 1 upon x, where x tends to 0 is log e to the base e, means it is 1. Okay, so this we need. Okay, this we need, so whole this term we need. Okay, so cos of x plus h minus cos x we need. Okay, this we need, this extra, so I will write cos of x plus h minus cos x, this extra. Okay, this extra. Okay, since, okay, keeping it as it is, limit h tends to 0. Okay, when h tends to 0, cos x becomes 0, therefore whole this term become a 1. Okay, whole this term become 1 when h tends to 0. So limit of h tends to 0. When h tends to 0, it doesn't have any effect because it's x. Okay, here we have e raised to cos x into, okay, now here we have to do is we have to rationalize its or you can do one thing, you can expand. Okay, cos c minus cos d. Okay, let's expand upon h. Cos c minus cos d is minus 2 sine of c plus d. Okay, c plus d means x plus h plus x upon 2 sine of c minus d, x plus h minus x upon 2. Okay, now this minus x plus x gets cancelled. Okay, so this h I can bring here h. Okay, this h I am bringing here, these 2 I can bring over here. Okay, here this x can cancel, we have h by 2. Now we have h by 2. Okay, when limit h tends to 0, this become 1. Okay, so e raised to cos x, we have minus 2 is already gone over here, or 2 is already gone over here. Okay, here we have minus 1, so minus when h tends to 0. Okay, here we have sine of x plus x is twice x by 2 is sine x. Okay, here is sine x. Let's see. Okay, differentiation of e raised to cos x is what? E raised to cos x, differential cos x minus sine x. Okay, this is the answer. Okay, thank you.